Okay. Good afternoon. Hope everyone had a good lunch. Welcome. So I'm going to talk a little bit about what Intel's doing to advance cloud computing, and specifically the performance that we're delivering, along with our partner Alibaba, to unlock insights from data analytics and artificial intelligence, and give you some idea of where we're going with that. I'm also going to talk quite a bit about the collaboration that we have, so you can get a better understanding of what does Intel do with Alibaba to make sure that you can get the best performance at the lowest cost for developer services or Alibaba services that they build on top of their cloud. So if you just take a look back at where we've been, Intel has been really at the foundation of a lot of the transformations that we've had in compute over the last decades, right? From the transition from mainframe servers to standard high volume servers that we drove back in the late 80s and into the 90s, to the internet and eventually cloud computing over the last 10 or 15 years. And when you look forward and you think about where we are today, pretty much everybody on Earth, as you know, is connected to the internet. And they're all generating lots of data and consuming lots of services. And that data creates an opportunity for new applications that kind of drives a virtuous cycle of compute and benefit out of that connectivity and the amount of data and services that are available. And when you think about everybody on Earth effectively being connected to the internet, we see that as people are generating, single-digit gigabytes of data every day, right? Either through the services they're consuming, like video services or other things like that, or what they're actually generating and putting out on the internet. But when you think about the future and you think about where we're going to be when we have more things and machines connected to the internet, the amount of data that's out there to be processed is going to explode, right? So we see that by 2020, we're going to go from about 1.5 gigabytes of data generated by each person through their phone or their PC or how they consume services on the internet. An autonomous car, through all the cameras and sensors and connectivity that they have, generated about over 1,000 times more data, right, per car than a human does. Connected plane, same thing. And you look at a smart factory with all the sensors and capabilities and real-time controls that you have there, and it's another 1,000 times. So when you start to think about the Internet of Things, you have to think about orders of magnitude higher numbers of data or amount of data that's out there. And then you have to think about what is that cloud infrastructure going to look like that's going to be able to store that data and transmit that data and compute on that data and connect all of the different devices together in ways that we can get new services that we haven't even thought of. And that's going to require an infrastructure that's got orders of magnitude more efficiency, more capacity, higher performance, and it's going to require artificial intelligence and other machine capabilities, learning and machine-generated services to be able to take action on that data and generate services, because there's no way humans can sit there and figure out how to make sense of that data. So artificial intelligence is just going to be a foundational capability of pretty much all services moving forward as we get into the Internet of Things and connected era. And so what is Intel doing with Alibaba to enable that? And if you just think about what we've done with Moore's Law and the advances we made in compute year in and year out, pretty much every year we reinvent the whole product line and the offerings that we have in the market. And we work with our industry partners, OEMs and software providers and cloud service providers like Alibaba to be able to deploy that infrastructure. And every year we deliver 30 to 40% more performance just across all general purpose compute for all applications every year. And that creates a tremendous, what we call a performance CAGR, or compound annual growth rate. And then on top of that, we add in more workload optimized or specific performance or total cost of ownership efficiency gains that we can make through microarchitectural advancements, system architecture advancements, new instructions, new features. We can target specific workloads. And we can, on top of that 30 or 40% performance gains we get every year with the latest and greatest technologies, we can get 2, 3, 4x performance gains through these more targeted technologies for specific workloads. And what you see here is just 3 examples of that, right, that I wanted to share with you. These are 3 recent technologies that kind of give you an idea of what we do. So I'm going to walk through those. So the first one is Intel Resource Director technology. This is really a technology that will help orchestrate the allocation of resources in the cloud. I'll show you how it works in a second and what it is. The second one is Intel Mesh Architecture, and this is a fundamental change in how we architect our processors that go into the cloud. and it was introduced just this year in Alibaba Cloud on the Xeon Scalable platform, which is our new processing platform. And then the third one here is another new capability in that same processor family, which is the AVX512, which is an extension of our traditional SIMD capabilities, but for high throughput vector processing, where you've got many data sets that you're performing similar calculations on. We can do that in highly parallel way. And again, to show you how each of these things work. But these are examples of new technologies that we deploy that make the cloud service on top of our architecture so much better. So the first one to kind of go through these is resource director technology. So this is a technology that we introduced on our previous generation CPUs that are deployed broadly today in the Alibaba Cloud. And basically what it does is it allows quality of service monitoring control between multiple virtual machines or containers on a system. So the system administrator can set policies to make sure that last level caches or memory allocation or memory I/O, bandwidth allocation, and things like that are maintained across multiple virtual machines. So one virtual machine can't hog resources from another if you don't want it to. So to kind of just show you a quick illustration here as an example. So we have like our layer 3 cache, right, which is a shared resource across multiple containers or virtual machines in a system. If you had 2 virtual machines running on a platform as an example, prior to resource director technology, it was somewhat random as to which virtual machine got more resources, right? And so you could have a virtual machine 1 that was getting starved for resources because virtual machine 2 is getting a higher allocation of that, maybe because virtual machine 2 spun up first and it took more of the resources. But if you can imagine, maybe virtual machine 1's a higher priority from a performance perspective than virtual machine 2. And so prior to RDT, you really couldn't control that. So now we have a capability that allows us to basically set VM priorities, again as an example, and you can fence off a minimum amount of resources for any given virtual machine that will be allocated to it so that you don't completely starve it. So the example you see on the chart here is I've got my low priority VM, which is in orange, and I'm going to allocate a certain amount of the cache to that. Now, if that's the only VM running in this example, it'll take as much of the cache as what it needs in order to deliver the best performance possible. Okay, but if I spin up a higher priority virtual machine, like the green one here, that needs some of that cache back in order to deliver its service level agreement or quality of service, then the resource director technology will basically reallocate the cache to the higher priority VM and just give the minimum required cache to the lower priority VM. And so therefore, you're basically getting an overall better system performance. You're hitting your service level agreements for the service that you're building on top of the cloud, and you're still maintaining the minimum performance requirements or resource requirements for the lower priority VM. So this is available today in the Alibaba Cloud for developers to use. The second example here of what we can do to deliver substantially better performance is the Intel Mesh architecture. So this is an all-new CPU architecture that we deployed in the Xeon Scalable platform that we launched in July, also available on Alibaba's Elastic Compute Service today. To show you what it is, basically is an illustration of what our CPU architecture used to be prior to the Xeon Scalable generation and what it is today. So we used to have what we called a ring architecture, which is we would connect the multiple cores and caches and memory I/O channels inside of a CPU to a ring. And if a CPU core on one side of the CPU needed to speak to memory or cache or a CPU core on the other side of the CPU, the data would travel around that ring until it got to its destination, and then it would get transmitted or read or whatever. In the new mesh architecture, the cores are more fully interconnected on a mesh, and so you can see that if you have data that wants to go from one side of the CPU to another side of the CPU, there's many paths to get there, and they're much more direct. And so that gives us a step function improvement in performance, where you have a lot of data sharing across multiple cores, multiple VMs, multiple memory channels, things like that. And the third example here, and this one has had tremendous results from a performance perspective. I think it's a really good example, is AVX512. AVX's advanced vector instructions is an instruction set enhancement to the x86 instruction set. And we've had AVX for a while. AVX 512 is the latest generation. It's for high throughput vector processing. We've doubled the number of transistors, gen on gen, and we've doubled the length of the vectors, the number of bits that you can put in each register, from 256 to 512, gen on gen. So that gives us a huge performance gain where you've got lots of data that you're performing similar operations on, like multiplies or adds, things like that. And you can see some examples on the screen here of specific applications at Alibaba of what they've seen as far as performance gains, where we've introduced AVX 512. So we've got security applications where we're seeing 2 to 3x performance enhancement. We've got high performance computing, which is generally a heavy user of AVX instruction set, where we're seeing almost 2x or 60% to 100% improvement depending on the application. And then artificial intelligence is also, especially deep learning, is a heavily vector matrix multiply and add kind of workload, and it benefits from AVX 512 as well. So we're seeing over 2x gains gen on gen for those kinds of workloads where you're maybe doing inference as part of your application, natural language translation processing or image recognition, things like that, or you're doing training on those models. We see a huge performance gain. So I share these as just examples of sort of recent architectural enhancements and features that we put into the platform that Alibaba has adopted, and they become part of the Ali Cloud. And that's, again, on top of just that generational kind of Moore's Law 30-40% improvement that we deliver gen on gen. And so we don't really just stop at delivering new CPU architectural enhancements and better performance for Alibaba. We've actually worked very closely with them since 2006 in developing their software applications and tuning them for whatever the latest architectural enhancements are in the Intel architecture. So we have our software engineers and hardware engineers work hand in hand with Alibaba's engineers, and we make sure that they tune their applications to basically be ready for those new instructions, to take advantage of whatever the I/O enhancements are, the architectural benefits we put in there. We have lots of tools and libraries that we work with them to make sure that they're available and part of their software stacks and part of the APIs and others that they develop. And again, there's 3 examples here of recent benefits that we've gotten from collaborations with Alibaba. The first one is their speech recognition, which is part of many of their applications, has gotten an 80% performance improvement just by implementing it on AVX 512 versus what they had on the previous generation. So I think a good testimony of what they can get out of that benefits all of their customers. The second one here is there's a new technology that Intel's introduced called secure guard extensions, and this is basically an ability to take zones of memory and basically draw a fence around it and protect it so that other applications cannot get access to that zone of memory. So it's like a highly protected memory region. And Alibaba is in the process of deploying a service that they're going to announce here in a few days that takes advantage of the SGX technology. And they're going to use it initially for key protection. So if you have applications that have keys that you want to keep, absolutely protected, this is a good place to put those. And then over time, they can open that up to more and more zones of applications where you might have sensitive data that you want to keep protected and sort of an ultra secure, think of like a safe within your application. And then the other thing that we've done is we've been working with Alibaba for 2 generations of CPUs now where we actually deliver custom CPUs. So when you're using the Alibaba Cloud and you're using either our Xeon V4 instances or our new Xeon Scalable instances, you're actually running those instances on top of custom CPUs from Intel. They're not the standard CPUs. And our engineers work very closely in our manufacturing team to be able to basically tune the features, the core counts, the frequencies, the thermal and environmental design points, the quality points, to really be optimized for Alibaba's environment inside of their data centers and get the best performance at the lowest cost for them. So that's, I think, a good example of what Intel does with Alibaba to make sure that we deliver the best platform and they deliver the best service at the best cost points to their customers. And so the first generation of that was deployed last year, and it actually Singles Day ran on top of those instances. And as you know, every year they break world records in number of purchases and purchases per second and things like that. But that all ran on a custom CPU last year. And the new instances with the Xeon Scalable that are available today since July are also on a custom CPU. So we're really pleased to work with Alibaba on those custom solutions and continue to kind of drive the future of performance and total cost of ownership. No audio.
One of our
Sorry, I stopped it. Okay, sorry. So now I'm going to show you a quick video, which has it has a couple of folks. It has one person that's from Intel. She's a peer of mine who's in charge of our cloud service provider business, and she's going to talk about what we've done with Alibaba for customization. And then we've got a representative from Alibaba that's going to kind of show you some of the benefits that Ali can provide their customers through some of the collaborations that we've done for custom CPUs.
At scale, every ounce of performance and efficiency matters. One of our partners with Alibaba in China, we developed a custom SKU that we worked with them to achieve better performance per dollar TCO of this generation of the Intel Xeon Scalable processor versus their prior instances.
英特尔自强可扩展处理器提供了全新的 CPU 微架构，在互联架构和缓存架构等方面的巨大创新，适用于多种的计算场景。阿里巴巴在此基础上做了进一步的定制，适应我们的业务场景。其中高频处理器获得了30%的 TCO 收益。
Okay. All right. Sorry for the feedback there. Okay.
At scale.
All right. Done. Okay. So I just wanted to share a couple of results, right? So we have tight collaboration with Alibaba. We continue to drive continuous improvement in the performance and the lower TCO of our platform in general. And I think that the results kind of speak for themselves. So here's some examples. We keep turning out world record performance, right, every year, which is really fantastic. 2 years ago, these are some artificial intelligence or data analytics kind of benchmarks here where you're doing image sorts as examples, but we did a gray sort competition, and we got a world record back in 2015 together with Alibaba, where we did a 100 terabyte sort of images, and we got it done in 377 seconds. So that was a world record at the time. Of course, that's been blown away now, but we continue to march forward. We did cloud sort, got another world record last year, and in that one specifically, it was the record was a cost per performance. And it was $144, which was a world record again at the time. And then just this morning, Dr. Zhou and I announced on stage the latest big data analytics benchmark on max compute. And there was a world record set that really blew away the prior records, where prior records were set on a data set of 10 terabytes. And they set a world record on a 100 terabyte set. And it had 7,830 queries per second. And it also set records for dollars per query per second. As well. So great results here, and I think a good testament to the capabilities that Alibaba and Intel build together to deliver a great performance that's available basically to everybody. And here's an example of what we can do when we provide that kind of compute performance to everybody. With artificial intelligence becoming something that's more mainstream now, and the availability of high-performance computing in the cloud, Intel and Alibaba teamed up with Tianqi Healthcare to challenge the industry and academia to figure out what could we do to go solve one of the biggest health challenges in China. And so about 2 million people or more every year die of lung cancer in China. More than 4 million people are diagnosed with it every year. And we wanted to challenge folks to figure out how to take advantage of the compute power that's available to come up with the best algorithm for automatically diagnosing lung cancer by looking at medical images, right? As you can imagine, having people sort through those takes time, and time to diagnosis is one of the best things you can go do to improve the treatment and the expected outcome from lung cancer. And so we challenged 500 participants. There were 500 participants that entered into the challenge. We offered 1 million RMB as a reward if you came up with the best algorithm using a 400 teraflop cluster that Alibaba stood up on top of Intel Xeon Phi platforms. And we announced the winners yesterday, and it was Beijing University won, and they were awarded the million RMB for their work. And I think it's a good start for starting to figure out how do we apply all this compute power to solve some of the biggest challenges and do some good for the world, right? So congratulations to that team, and hopefully it's inspiring for everybody to figure out how do we apply compute to real human challenges. So with that, I thank you.